Hello folks, welcome back to my YouTube channel. This is Devanshan, and in this video we'll be learning about we'll be learning how we can code a pre-order traversal of a binary tree. So if you are new to my channel, please do subscribe my YouTube channel, and also if you have not watched my previous video where we basically learned how the pre-order, post-order, and in-order traversal of a binary tree works. Okay, so simply in this video I'll be basically showing you the code how you can code pre-order traversal, and in the upcoming videos we'll be seeing different traversal techniques. Okay, so yeah, let's get started. Just a quick revision. As we know, in pre-order we have this, we first visit the node and then the left side of the particular node and then the right side of the particular node. Okay, so just focus on one parent node, and first of all you need to visit the node itself, and then you need to visit the left side of that node and then the right side of that node. Okay, just these simple steps. So let's try the code for that. First of all, let me okay, what I'm doing is I'm simply writing the method. Okay, let's this method will be you can keep it as public. Okay, public static. Let's say, will this method return anything? No, of course it won't return anything because it's a simple traversal. So we'll keep the return type as void, and let's name this method as pre-order. Okay, let's name this method as pre-order. Okay, before that, what all arguments you think this particular method is going to take? Of course, it's going to take the root. Okay, it's going to take the root. Okay, which is of type node. Okay, root of type node, and a node is basically a custom class. Is a class. Okay, which we have created. And if you have not watched my implementation video, you should definitely watch that. So yeah, and what else? What else you think this do we need for traversal? Nothing. I think it's fine just to have a root, and with the help of that particular route we'll be able to traverse the entire binary tree, right? Yeah, so the very first condition or the very first case would be, suppose our root is null. Okay, yeah, that's a very much possible case. So in that we need to handle this. I'll say simply if my root equals to null, and in that case what I'll do is I'll simply return. Okay, so yeah, if my root becomes null, and I'll simply return. Cool. So now what's next? Okay, first case we have handled is if our root becomes null, then simply return. Now the next thing is, according to a formula, I'm simply saying this as a formula. Okay, this is basically a basic algorithm, right? Of a binary. Basically, it's a basic algorithm of pre-order traversal. How the pre-order traversal basically works. Okay, so first we visit the node and then the left side and the right side of that node. So let's implement this. How we can implement this? So this particular node means visiting that particular node basically means printing the data of that particular node. Okay, so how do you print the basically how do you print data of a particular node? By simply saying system dot out dot print ln, and inside this what we'll see is root dot data. Okay, because that root, that particular node has three properties. Okay, first is it has a left node and the right node and a data associated with it. So we basically want to print the data. Okay, so this node basically means printing that particular data of the node. So we have done that. Okay, okay, after that what is the next step? Next step is basically to visit the left side of that. How would you visit the left side of this particular node, root node? Just focus on this particular node. Okay, on a single node, by simply calling the root dot left, right? Am I right? Yeah. So what how we can do is we can simply say pre-order. Okay, call this pre-order with the root dot left, and then do the same for the right side, because we know after visiting the left side we need to visit the right side of that. Root dot right. Okay, cool. That's it. So this is the entire code of pre-order traversal of a binary tree. So what now, if you have any confusion how this is working, then you can simply take a pen and paper, and you can simply execute it. Okay, so using stacks. Okay. Yeah, so just a quick summarize. I am summarizing works on the principle of a leap of faith, a recursive leap of faith. You only need to focus on a particular node. Okay. Suppose you are given a particular node which is root. Okay. Now you have to perform the binary traversal on basically you want to perform the pre-order traversal on this particular root node, right? So according to our pre-order traversal algorithm, we have this NLR. N basically means you need to print the data of the node, and L means visit the left side of that particular node, and R means visit the right side of that particular node. So, coming inside this method, the very first edge case or the very first possible case would be that our root is null, right? So I'm simply checking for if my root is null, then I'm simply returning from here, right? Because that does not make any sense if my root is null. Okay. So after that, what we need to do is we need to visit the n. And basically visiting n basically means printing the data of n. So what I'm doing is I'm simply saying root system.println root.data. And after that we have this left. So visiting the left side, how can we visit the left side? We can simply call the pre-order and pass the root dot left for that. Okay. And for the same we'll be doing for the right side as well. And now you can simply you can simply call this pre-order method in your main function, and you can simply pass the root. Okay. So yeah, that's pretty much. And thank you for watching this video. And if you like this video, then please do give a thumbs up. Okay. So yeah, thank you.